So, reporting to you from BBC News from Tokyo, Japan.
So what are adaptations?
An adaptation is a trait that helps an animal adapt to its environment. To be more specific, it's a process of change of an animal or organism that helps it suit to its environment. The species with the best adaptation will most likely survive the longest and reproduce its offspring.
Oh, so it helps the animal survive the longest and have better traits to pass on from generation to generation?
Yeah, exactly. So the next generation that had the same traits as the animal will pass them on.
But what is natural selection? How is it used?
Great question. Natural selection is the process of where an organism is better adapted to its environment and tend to survive and reproduce more offspring.
What's an example of natural selection?
Another great question. An example of natural selection is the moths. They are an example of natural selection because the dark moths tend to blend into their dark environment while light moths do not. So therefore, the dark moths will survive longer.
So the better suited animal with a better adaptation will have a better chance of surviving?
Exactly.
So how do scientists use anatomy to show evidence of evolution?
Well, scientists use embryos so we can see the vertebrae, the tailbones, such as in animals or reptiles, such as fish, reptiles and humans.
What are two examples of homologous structures, similar bone structure?
Well, they also use a similar structure under skin from cats, whales, bats, and also humans. They have all similar arm structures. They have leftover structures like whales with a pelvis and a leg bone.
What is an example of structures that are still in animals or their fossils aren't used anymore, which are vestigial structures?
An example of vestigial structure is whale legs and pelvis structure that hasn't been used for a long time, which is a structural change over time. Structural change over time is how much a living organism has changed in its body, structure, or body functions over time.
Oh, so how do scientists compare embryos to support evolution?
Scientists compare embryos to support evolution by taking one embryo, taking another embryo, and comparing them to each other and find out similarities and differences they have.
What are some examples of embryos might they have to prove evolution?
Well, they use the vertebrae and tailbones that are in fish, reptiles, and humans. These are extremely similar to each other.
Well, anatomy has many things included, but I still have two more topics I want to cover. Next one is, I would like to know about fossils.
Well, fossils, not much is included in that category, but what are your questions?
How old is Earth, and how do we know using rock layers?
Well, that's also a good question. Earth is about 4.6 billion years old. We use radioactive dating to find out how old fossils are by finding out how far down in the structure it was. We can use radioactive dating to find out how old Earth is because radioactive dating is only for fossils.
Whoa, so Earth is really old. Are you telling me that the deeper the rock is, the older that it is? That's cool. How do fossils give evidence that support the theory of evolution?
Fossils show, firstly, that life has been changing over time by using radiometric dating, and shows how older or how new the structure got over time.
What is an example or case study of a series of fossils that support evolution?
An example of fossil case study is a fossil of an animal or living organism that used to live a long time ago, and you can match how much they have changed and match them to how the animal that is the closest match the animal that lived a long time ago.
Alright, finally, this is my last topic. It's DNA.
Ooh, DNA. This one is pretty complicated.
How do scientists use DNA to support evolution?
Great question right there. An adaptation is passed from one generation to another during reproduction, and it gets its genes and it gets into the Okay, guys, stop. Okay. I can't. Okay. By living organisms survive longer and pass on the gene trait to make the next organism have the trait and be able to do the same thing as the animal did before.
That's a lot.